Alright, welcome back everybody. My name is Dustin, and in this video we're just going to go over this little rain generator that I made in our engine here. So I wrote the rain generator in Lua, however I had to make some changes to the underlying engine in order to get it to work properly. So this is basically what it is. So what we did is we created a rain object here, and then the rain object has different parameters that we had to give it. So we have the initial position, the velocity, min and max velocity, because we don't want them always to be going at the same speeds. So we have a min and max velocity. We have a lifetime, and down here we end up with a min and max lifetime as well. Because we're going to have a random value for the lifetime of them, because eventually they're going to die for us. And we have alpha. Do we want it to be alpha, the width, the height, the texture? And then we also give it a life timer. So down here, we create our entity. So each raindrop is basically an entity that we control. And we add its components that we need. Our sprite component, color, the alpha. Then down here, we start our timer right away when we create the rain. And then down here, we have a few different functions. The rain life over. All it's doing is checking to see if the elapsed time is greater than the lifetime. Then it returns true if that is the case. And then we have the update function. In the update function, it just checks to see if the entity is not nil. And then if it is nil, we return it. And if not, we take the transform and the rigid body. So we do a rigid body component. And then we change the position based off the rigid body velocity and multiply it by the delta time. Now, we didn't have the rigid body component, so that's one of the things we had to add. So we had to add this in, the rigid body component. All that is the velocity right now. We can add other things. Now, these are different than physics, okay? So we still have our physics component, which has its own rigid body. However, we're not using physics with this. It's just something that we render to the screen. And we want to be able to move it. So let's go back to the rain generator.lua. And then we also give it a little animation. So we give it up here. So if we check this out. So the local animation, this is all I gave it. So the entity, we're adding an animation component. We're giving it a 0 for the number of frames. I just want it to start at 0. Now we can add that in as another parameter, but for now we just left that as is. And if we go down here, check out the finish function. So what it's doing is checking to see if the entity is nil. If it's not, it comes in. And then, so we've got to our finish function. Inside of it, it checks to see if we have started our finish. If it has not started the finish, it'll stop the rain. Then it'll change the number of frames to the desired number of frames for the animation. Let's take a little look at the animation that we created. I ended up creating this. Now, I didn't actually create the original. The original came from right here, from Open Game Art, not this particular one here. It's this raindrop. However, it came in 5 separate images. So what I did is I opened each image and copied them into a sprite and made it into one image, but with 2 different directions. So I ended up changing, I'm just flipping the sprite to different directions. It makes it easier for us to manipulate. We just move it over our UV values in order to change the animation. But while it's falling, I don't care. I just want it to stay on this. But as soon as its life is over, we want it to do the splash. So that's what we're doing here. So if we see this here, this is what we're doing here. We're doing the splash. We're stopping it from moving, changing our number of frames, and changing the start finish to true. So next time it loops around, it's not going to go here. It's going to go in here, and it's going to see if the current frame is equal to the number of frames minus 1. So that means it's at the last frame. So this is not a non-loopable. So if we go back up to our animation here, animation component, see it goes false, false. So it's vertical. No, it's horizontal. And is it looped? No, it's not looped. Okay, because we only want it to happen one time. So after it goes to there, it checks to see if it's made it to the final frame. And then it's going to reset the animation, reset the number of frames back to 0, get the transform position, reset it back to the initial position. And then we're also going to set our UVs back to the initial U value at 0. Because we're moving horizontally, I don't care about the V, I only care about the U. And then, now we want to change the velocity to a random value because we don't want it to be the same, but we are putting it back to its initial position. But we don't want its velocity or its lifetime to be the same. Then we have to reset the life timer and then also start this finish. We also have the destroy function, which will kill the underlying entity and set the entity to nil. That's where we come into the rain generator class. This is a Lua class as well. And the rain generator will also have parameters. So we have an X offset. If these aren't sent in, they all come with default values. The same with up here. I gave it all default values if nothing was sent in for the parameters. So in here in our generate, so what it does is it has these default values for our raindrops. Then we end up having a rain table. So that's where we call this regenerate function. So here in regenerate, what it does is it checks to see if the rain table is 0 only, because we want to do this, we want to be able to regenerate and destroy. So if we destroy them, basically shut off the rain. That's down here. So we'll destroy the rain, and all that will do is call the destroy function for the raindrop itself, and then make that entry at the table. So rain table at k equal to nil. Okay. Then that will allow us to regenerate. So it's like stopping and starting the rain. So in order for us to do this, we just basically get the camera scale, and then we get our max width, max height, and then I made these little helper functions, window width, window height. These are functions that are coming from the engine itself, but we'll get to that. Same with this random function. So we go through all this, so we end up with our max height, max width, divided by the offsets. That'll give us our rows and our columns. Then we do a double for loop between rows and columns, and we get our start x based on the offset times j. And then, so we're clamping it. This is the value coming in, clamped at 0 to the window width minus 1. And the same with the y, we're doing the same idea. Then we want to get a random velocity for the rain, and we take in the random velocity minimum and the random velocity maximum that we sent in, and we want to get a float value back. And then those are just set here as basically as our params. This here is a table that we're sending in, and it's our position, velocity, and our lifetime. Our lifetime is also going to be a random, okay? And that's basically how we wrote the rain generator in Lua, and we got this here. We run it, gives us this rain here. Okay, so let's close this real fast. And the sound, I also grabbed that from OpenGameArt. So the sound I use for this is the raindrop here. Oh, not that, sorry. It's this one here, Rain Loopable from OpenGameArt. Both of these are CCO, so they're in the public domain. Both of these, so you can grab them. The link will be in the description if you want to grab these yourself. And in order to get that to run, in our main.lua, right before we get into the update, I call our sound.play right here. And I'm calling the rain sound and -1 and channel 1. So -1 means loop forever. And we just want to put it on channel 1 for now. We don't want to find it there's probably no other channels being used, so I just put it on channel 1. Now here, this was just a little test I have. So we're updating our rain, so it's moving. And then down here, I just did a little test to see for the destroy and regenerate to see if it works. And it works fine. So let's go over a couple of the functions I had to add in. So up here in our scripting system, in our register Lua functions, all we had before was the run script. So I added a few other ones. Right here was the Lua set function get ticks. I added in the measure text because we needed that one. So it'll take in a text and the font name, and it'll grab the font from the manager and do all of that for us and send us back how wide the text is. Then there's some other functions that I did some wrappers for. The get delta time, the window width, window height. This is just a Lua set function, and I'm just returning the current values that are inside of the core engine data. And we went over the core engine data in the last video. Disable physics, enable physics, is physics enabled, stuff like that. Then there's also this random generator that I created. So let's go to this class. I had to create this because I was using the get ticks at first in the rain generator to get a random value. So I had a function. I deleted the function, but we'll just quickly write that function right here. So let's just go to main.lua. And right here, I had a function. And it was just function, and it was just called get random value, okay? And that took in a min and it took in a max. So what I was doing was I was getting the math.random seed, and I was using the get ticks function to give me a different value for our seed. And then I was going to return math.random, and then I had the min and max values. Min and max values. Now, this worked great at the beginning. The only problem is it worked fine in debug. So up here you see I'm in release. Well, before in debug, it was working fine. I was actually getting decent random values. You guys understand how it's pseudo-random, but it was decent and we weren't getting the same numbers. However, as soon as I put it into release, inside of our function here, so anywhere we were calling random multiple times, so here in the random in our finish, so anytime that we were calling the finish function, it was going too fast that I ended up getting the same numbers. So when the raindrops were falling, they were getting the same lifetime, same velocity. So it kind of just looked like a straight line of splashes. And it didn't give that random look. So that's when I created the random class. So here in our utilities, I ended up adding this in, the random generator. And all this does is it takes the MT19937 random engine, and then we use a uniform int distribution. So these constructors, let's go over to how this is done. So we're just seeding it based on the random device. And then we have our default constructor, which just calls the other constructor, but gives it two values, 0, and then your numeric limits for the max of Uint32T. And then inside of this, we are just calling our initialize function, which does our seed. And then here, we're getting our get float and returning a distribution, casting it to a float of the random engine. And then we're also, this one is get int, and it's just returning the Uint32 or an unsigned int value, okay? So after we do that, a link to this will be also in the description. This here, the MT19937, or the Mersenne Twister pseudo random generator. This here, this will be in the description as well, so you guys can get a bit more information on this and how it works, okay? And then after we took that, we did our binding. So we went to our scripting system here, and all I did was create a random generator binding. It's a new Lua user type, and we just called it random, and we call it constructor. This one uses sole constructors and then has two different constructors, the default constructor, or we're sending in our min and max values, okay? Then we have our get float and get int, and once I started using that, it worked fine. So inside of release, I'm now calling the random, sending in our min and max velocities, and I'm getting a float value back. And that was working perfect for us, okay? And that's really it. And so I just created this random. So you can change, it doesn't have to be rain, it could be anything really. I was actually playing The Legend of Zelda, A Link to the Past, and then the rain at the beginning of the game made me want to create this for my own. So when you run it, you can get your rain flowing. And we created this map using tiled, and we already did this in a previous video. And we're loading this using our utilities. If you remember from before, we're doing this with our utilities function. So in here, we have our utilities.lua. And utilities.lua, this is where we're loading it in our load map. Okay, so we're taking the map that we created inside of tiled, the tiled map generator, because right now we still don't have our own map, tile map editor. Eventually we'll get into that. But you can just use tiled and then load them how you want them. You just have to create these wrapper functions. And right now we have our box colliders, but we're not drawing the box colliders because I'm currently telling it not to draw them. So if we go back to our shape system here, I created another function, or a variable basically, in the core engine data, and it's render colliders enabled. Right now, it's not enabled, it defaults, but we can have these enable and disable functions. They just need bindings to them, okay? So that's it. That's how you create a rain generator. Now, do you guys like this style of format where I just write the code already, like previously write the code and just go over what I did? Maybe give me some feedback on that, or would you like me just to do it with you, where we go over how to do it ourselves, go together, or my implementation? This is all going to be posted to the GitHub, so if you want to try it out, go and grab it. Also, the links will be in the description for the raindrops and the sounds themselves. So try to play around with it yourself. The current state of the engine, you can actually make a game with it right now. The way that it is right now, you're going to have to use other tools like Tile to make your levels and stuff like that. However, the functionality is there to play music, do scenes, do all your scripting, do the rain animations. Like I made very small changes to the actual engine to get this to work the way that it works now. So you guys can do it as well. Let me know in the comments below if you've tried to make a game using our engine. And if not, no worries. I'm currently working on the documentation for that, and it'll have examples on how we created, and we're also going to go over how to create some more in the future. All right, that's it for this video. We're going to start getting into more creating games and future videos coming ahead. I just wanted to go over this cool, at least I think it's cool, the rain generation and how I did it. All right, take it easy.